Okay, hi Year 11s, we're doing 7b. Now if I can just open up a grid paper, there we go, that's what I want. So hopefully you can see that fine. So let's rock and roll here. I'm going to try and do this question without a calculator. We need to write as a terminating or recurring decimal. Right. These are rational numbers. Why are they rational? Because they can be written as a fraction. Okay. So what is it? 13 on 25. This is 7b. Whoop, that's not working. I'm going to show my little pen tool. There it is. 7b, question 1a. And the fraction was 13 on 25. Now you could just go to the calculator, but it's probably more fun to do it this way. If we were to do this division like so, right? We say how many times does 25 go into 13? Well, it doesn't, right? But if I made this like 130, how many times does 25 go into 130? Well, 5 times, right? Because 5 25s are 125, or 0.525s are 12.5, and then you subtract that away and you're left with 0.5. And you just think of that as the number 5, right? So it's 25 going to 5? No, it doesn't. But if I brought another 0 down to make it a 50, does 25 go into 50? Yes, it does, 2 times. And it does so with 0 remainder. So we are now finished with that fraction. Let's have a look for another one. What about 5 on 7? That'll get a bit long, but that's okay. I'll just draw a line in the sand here. There's a little line on my page to separate things. 5/7. Okay, without a calculator. Right, so we're looking at 7 into 5. Remember, fractions are like they are a division, right? So 7 doesn't go into 5, but it will go into 50, and it will go into 50 7 times, right? 7 times 7 is 49. 50 minus 49 leaves you with 1. Right, 7 doesn't go into 1, but it does go into 10. And it goes into 10 one time. 1 7 is 7. Sorry, mistake. Try that again. We're down here, 0.07, and we'd be left with 3 when we subtract that away. Right, I'm going to stop writing the decimals at this point. So 7 into 3 doesn't happen, but 7 into 30 does. 7 into 30, well, 4 7s are 28, so we can get a 4. We need a bit more space here. 4 7s are 28. Subtract, we're left with 2. 7 doesn't go into 2, but it will go into 20, and it will go into 22 times. 2 7s are 14. 20 minus 14, 6. Add your 0. 7 into 60. Well, 9 7s are 63. 8 7s are 56. We can get 8 7s. 8 7s are 56. Subtract 4. Add a 0. 47. How many 7s in 40? You've got 5 of them. And at this point, we're going to be back to where we started. 5 7s are 35. Apologies, this pen's quite difficult to use. 5 sevens are 35. Subtract that away from 40 and you're left with 5, right? And can you now see that if we were to continue on, it'd be like here, right? The chain would just go the same and keep repeating itself forever. So I'd do 7 into 50, well, 7 sevens are 49, so I'd get a 7 and I'd be back to this point there, right? I'd be back here at a 7, I'd get another 7, 1, 4, 2, 8, 5, and that would keep repeating. So what I could write for this question is, I don't know how to get rid of that now, okay. I could say 5 sevenths equals 0.714285 recurring. If you can remember that sequence of numbers, you can use it anytime you see sevenths, although the order of the numbers changes. Okay, let's look at the next question. The next question. Show that these numbers are rational. When are they starting? I might start. No, we'll start with the easy one. 7 ninths. 0.7 recurring. Okay. So we've got 7b. We're up to question 2. They have this decimal number, 0.7 recurring. All right, this is how you can convert this to a fraction. So you say let x equal this number, 0.7777 with recurring sevens. Now, if I was, because my recurring starts in the 10th position there, in the first decimal place, that is my little cue to times this by 10. Now I'm going to consider what 10x is. It's 7.7777 recurring. How could I use this information, or these two values, x and 10x, to get to something with no decimals? I could look at 9x. I could do 10x minus x, just would leave me with 7. Right? So these questions are really quite neat. Therefore, x would have to equal, divide both sides by 9, 7 ninths. Tick. Done. So that was A. Let's look at the next. We'll do C, 0.324. Okay. So C, 0.324, it's all recurring, which means there's another 324, 324, 324. If I looked at going to the thousandths, that's where the recurring pattern goes. We've got tenths, hundredths, tenths, let me say that again, tenths, hundredths, thousandths, right? So x is 0.324, 324, 324, you get the idea. 1000x, 1000x would be 324.324, 324, etc., etc. These are recurring. So if I took that number and subtracted away this number, I would be left with a whole number. So 999x would equal 324. Okay, that means x, so therefore x has to equal 324 divide 999. Okay, now at this point my times tables aren't great. But I can see that this would simplify, and I'm going to have to do it the long way, I think, although a calculator would be nice at this point. I'm pretty sure these will divide by 9, but 270 plus 54. Let's just divide it by 3. Okay. The way that I know that 324 divides by 3, what you do is you go 3 plus 2 plus 4 equals 9. And if this number here divides by 3, the whole thing divides by 3. Okay. So that equals dividing by 3. How would I divide that by 3? I'd have 100. Divide 300 by 3, it's 100. Divide 24 by 3, and you're left with 8. 108. Well, 108 divides by 9. I'm pretty sure that will also divide by 9, but let's just divide them by 3 again, because we'll get there in the end. 1, 1, 1. That will divide by 3. That'll be my next step. 108 divided by 3. Well, maybe if we went to 90, 90 divided by 3 is 30, and then that would leave an extra 18, so this will be 36. Let's divide by 3 again. We'd have, what's 111 divided by 3? It's 37. We just looked at 108 divided by 3, didn't we? 37. And 36 divided by 3 is 12. And that is as far as you're going to be able to go with that fraction. Okay. Now, I think I might just do one more. Then I'll stop the video. Because what you may not have realized is in these two examples here, they start repeating right from the get-go, if that makes sense. As opposed to, what about if you get a recurring decimal, but it doesn't, or a recurring pattern in your decimals, but it doesn't happen straight away, like this number. Right? So here the recurring starts in the hundredths, right? So we say x, and the 8 there, well, you know, we're going to have to deal with that. We're going to have to go to the hundredths before we see the recurring happening. So we've got x is 0.8333, lots of threes. If we go to 100x, we'd have 83.333. But if I do 100x minus x, I'm not going to get a whole number, am I? Right? Because I'd be doing 0.3 minus 0.8. Yeah. What does that give you? It's like doing a 13 minus 8, isn't it? It's going to give you 5. But what you could look at is a 10x. What's 10x here? It's 8.333. And then you could use the 100x and the 10x to consider a 90x, which would be 83.333, subtract away 8.3333, and that would leave you effectively with 83 minus 8, which equals 75. Therefore, x equals 75 on 90. These will divide by 3, but let's aim a bit higher. Let's divide them by 15. So 75 divide 15 is 5. 90 divide 15 is 6. And that's as far as you can go with that one. Okay, thank you for watching, and we'll continue in a minute.